Hi, my name is Jonah, and I'm presenting our demo for our Conway's Game of Life openacc project. So, it's a brief reminder of what Conway's Game of Life is. It is a cellular automata where each cell in a 2D world is updated based on rules, or updated just based on the state of its 8 neighbors. I won't go into the details, but there's more info in our paper. Here's some example of these rules being applied. Yeah, so I'm just going to follow our README, which includes the replication instructions from the paper. This repo has already been cloned, and I'm in the project. So I have VS Code open, and this is SSH'd into a Linux machine that's just a few feet away from me. This computer has an RTX 3060, 12 gigabytes. This is a pretty common NVIDIA GPU. It's important that it's an NVIDIA GPU because AMD requires a different process to configure a 7600 Ryzen 5. Also common, it says 6-core CPU, 16 gigs of DDR4 memory. This motherboard. So, onto the instructions. We already have it cloned. So, we have a setup script, and this script automatically installs all the dependencies that are required for this project to run. But this computer is already set up, so it's just going to go through and say, yep, openacc, Python, already installed, virtual environment already exists, GCC, NVIDIA drivers, CMake. We don't actually need CMake anymore, but build essentials. Yeah, so goes through and installs a handful of things. So if this was the first time, I would have to reboot the system for the NVIDIA drivers to activate. But I'm already set up, so the next step is just to run make from the root directory. And this will just produce this build directory, and you can see our binary in here. All the other compiler stuff is in there, and then we can go ahead and run it. So our project does not, so instead of having two separate programs, one CPU, one openacc, we have one program that contains both implementations. And we have some intricate benchmarking logic and infrastructure to essentially sweep over a few interesting parameters. So the one that's updating right now is the size, I believe. We can actually verify that if we go to main, not that main, this main. Yeah, so the sweep parameters function, it goes through, and the first thing we do is we explore the width and height. So all the other parameters are fixed. There's some others that are defaults, but we sweep through the width and height, as opposed to just running one fixed benchmark versus another fixed benchmark. This gives us another degree of another thing for us to explore in our paper, let's say. And the next thing that we explore is iterations. And then these are written to JSONs. Okay, so this is going to take a while to run, so I'm going to stop the recording for now. Okay, so the benchmark has finished. So what this has done is it's produced these two JSON files, and we can take a quick look at these. Change iters. This is the run that fixed all the parameters except for the number of iterations. So we can see here width height 1024, number of jobs 4, iterations you can see it increases by 2, starting at 2 up to 64. The seed is fixed, and we run it for both benchmark types, the GPU and the CPU, and intertwined in here is the results, duration. So this is not very human readable, so what we have done is we have made a Python script to visualize these results. So I'm going to continue to go through the instructions here. Okay, if one wants to generate plots, so the setup script we did earlier actually made a Python virtual environment that we can go ahead and use. So from project root, I'm in the project root. We're going to go ahead and run this. We're in that virtual environment, and then this is the command we used to produce the plots in the paper. So this creates 8. It creates 2 plots per benchmark and 2 variations per plot. The 2 variations are linear and logarithmic. So we can take a quick look at these. There's efficiency and duration. So efficiency is just duration divided, or cell updates divided by duration. So you can really see that the GPU massively outperforms the CPU. Then we have some strange behavior, and some of these due to likely proprietary GPU scheduling behavior. That's my theory at least. But there you have it. This is our project results. Hope you enjoyed the demo.